and lead you through my presentation, which will cover the topics Vega just mentioned. So in the first part, I will speak about the upgrades of Libera Spark, and then on the Libera Briliance Plus instruments, I will describe what upgrades we did to the upper software layers in general to all the instruments, and then we'll present what we are doing at the moment and what you can expect in the next few months. So just 3 slides of the evolution of the Libera Spark. This was the first version of the Libera Spark developed in 2013. It was a very simple device with no attenuator, with no SAW filters in the beginning, no PLL, no Libera base or other easy software interface, but just a Skippy interface. But the instrument was performant enough to be installed at ERXR booster ring, and it is still in operation since 2014, I believe. And a few years later, we introduced another version of the Libera Spark, which we now differentiate by the name. ER stands for electron ring, and XR, it means extended range. And this means that we added a programmable attenuator to the front end. We improved the front end with additional filtering components, amplifiers. We added the PLLs, and we also introduced, let's say, the standard software framework to the instrument, so it can run Tango and Epix interfaces. And also during the time, we added the real-time data output for the streaming data, and there was also a minor change in the let's say only the label, where we swapped the B and C channels. And then 10 years after the first version of the Spark, we have another version right now, which we still name as ERXR, and the first machine that will run, or maybe even runs, this version of the Libera Spark is in Berlin at BSE2 storage ring. Compared to the version 2016, the major difference is in the even more extended dynamic range, I mean the input signal range, and it has an option with this additional connector to provide the sampling clock from, let's say, some external source. Even before, we had space for additional outputs and inputs, which is these are the interfaces located at the right side of the instrument, of the back panel, where we have the interlock output and additional trigger and analog and digital interfaces. So this is the latest the latest version of the instrument that is available under the name Libera Spark ERXR. And what the latest hardware upgrades meant for the, let's say, the quality of the data. So as I mentioned, we have additional 15 dBm range. So we can extend the RMS performance to higher input signals, up to 5 dBms CW. So on this side, we have the RMS for the turn-by-turn, 10 kilohertz, and slow data. It means, let's say, this data presented shows the bandwidth 400 kilohertz, 2 kilohertz, and 4 hertz. And on the right side, we have a plot of the big current dependence measured on the test bench. So overall, over the whole range, we can keep, with calibration, we can keep the current dependence below approximately 2 to 3 micrometers. And this additional source for the, or alternative source for the sampling clock, it means that internally we bypass the PLL and the oscillator, and we switch the source for the ADCs to the external interface. I don't have any comparison picture or the plot of the RMS or of the data, so hopefully maybe we can get something from the measurements with beam. Okay, so that was on the hardware side. So on the software, on the Libera Spark, we haven't done any upgrade of the operating system since the introduction of the instrument, and last year we made this major upgrade to the new operating system, which is called, we call it Neon, and the major improvements were in the processing performance. So the floating point operations, it can handle them at least twice faster. The operating system, it runs, or it has Python available to run the scripts. We have some additional drivers for the USB devices, and one of the things which is also new with this operating system is what Aleš presented before. We can provide this operating system, even the sources of the OS, to the users, so you can build your own OS from the sources. On the Libera software, so that was on the operating system. On the Libera software, we, I would say, just added support for the new components, like the additional attenuator, the sampling source selection, and we did some changes to the position calculation equation. There were some requests coming from APS in this field, and we simplified the handling of the calibration factors for the attenuator. Okay, so that was part of the Libera Spark. Now coming to the Libera Briliance Plus, on this right side we have, I have three photos that show, let's say, three generations of this instrument. The first generation was introduced in 2010, and you can see that, visually you can distinguish between the generations. So the first installations were at TPS in Taiwan, and then Max 4 in 2017, I think, 2016, 17. There were a couple of installations in Australian Light Source and Sesame, and then the latest installation, which is shown on this lower picture. This is the version which is installed at APS, and if you can have a closer look, this is the BPM module generation 1, BPM module generation 2 and 3. And all three modules can work at the same time in the same crate, running the same software. So changes in 2023, 2024. So we have the Kintex UltraScale Plus running in the BPM module compared to Vertex 5 in the first generation. We can support external switching matrix using the third generation module. We have changed this computer module here, which runs the CPU that has a production lifetime guaranteed at least until 2030. And also the big step forward is usage of the 64-bit operating system, where we can address much more memory. So basically these new CPUs can run, we can equip them at the delivery with 16 GB of memory, which is sufficient for all the operations. At the moment, we are running two development projects. I will briefly mention them even on the next slides. One of the projects is to refresh the timing module, which hasn't changed. This is the event receiver module, actually. This is still running the original generation, and now we are doing a refresh of the hardware components, and we will use the Artix FPGA. And we are also at the same time working on the major rework on the CPU module, on the computer module, which we call ICB. And this will be a second generation with many components, let's say, refreshed or completely new components. And we also intend to use newer generations of CPU. So the Briliance Plus, it's only let's say, the old name for the instrument, but it runs the latest hardware technologies components. I would just briefly touch on the, it says, modules that fit into this same family. One of the modules I mentioned before was this crossbar switching matrix, which we officially call Libera XBS, crossbar switch frontend. And this is just putting the switching matrix closer to the BPM, to the pickup. And this is intended to compensate the drifts over the long RF cables. And the other, say, sister module that doesn't fit into our high-tech chassis is this RTM module, which is going to be used at Petra 4 and fits into the micro TCA.4 crate. But the, say the main specification is more or less similar to the Briliance Plus. On the software side, on the operating system, actually, there were some changes which seem very small, but they were quite significant. We support now the network boot for the Briliance Plus and this type of instruments in general. This is the scheme how this network boot should be configured. I will not go into details. It required an upgrade of the Linux kernel, which consequently required also a bit more major change on the software we provided to users so far. And this year we started to work on the Ubuntu 24.04, which will I think it will be released in these days, in this month, of course. And this will be the next OS which we will run in the platform, in this Briliance Plus and its sister instruments. On the Libera software side, so this was the operating system. On the software side, we worked on the Libera grouping functionality a little. We added more diagnostics options. We reviewed how this daisy chain works, how to optimize the transfer speed and to reduce the latency. Then we introduced a new fast orbit feedback application to the central module, to the GDX module that has the real-time streaming data. We are going to deliver this application in about 1 month. And one of the, let's say, very challenging things, I would say, was also how to make or how to merge the code that runs in the Briliance Plus and in this micro TCA crate, how to merge them into the same application branch. And our developers managed to do that, and I think this was a very big achievement. So we have one source that we can, let's say, modify the function only on one place and dispatch to many, to both types of platforms. So the upgrades were done also on the client interfaces. On the Epic side, there were some bugs that were fixed or some updates done. But the more major update is coming now, where we are going to support more Epic 7 functionalities. And my colleague Alesh, who presented the software presentation before, he's already working on this. And also thanks to Gunther to suggest more features. And there were also some very important updates done on the Tango device server, and that was done in communication with Soleil. So one of the biggest steps forward were that the Tango device server can run on the separate PC, not in the instrument, but it can run outside. And the other improvement was that we can have many independent device classes that can run for the module separately, not merging functionalities from many modules. The work in progress, we have the even new development branch open for the Briliance Plus, where we are working. My FPGA colleagues were working on the DDC filter design. So we don't want to have hard-coded coefficients for the DTC filters, but our developers produced an FPGA design that is uniform for all the accelerator parameters, and only the coefficients has to be loaded to these filters. This is running already, and we have a comparison frequency response of comparison plot between the classic implementation, the orange one, and the blue one. It's the new one with configurable filters. And this is also one thing which I mentioned before. So we will have a new second generation timing module and second generation ICB module, and you could tell the generation by looking at the dots on the front panels. And yeah, we just have very little space on the small modules, but yeah, there will be dots there, so we can distinguish the generation by this. And this is just a render right now and not a real image, so you can expect few updates. Okay, so as a conclusion, I can say that we are living with Libera Spark for 10 years already. There were a couple of generations that the instrument went through. The Libera Briliance Plus is around for 14 years. And I would say that all these instruments, including the micro-TCA platform, they share the common core functionalities, which we concentrate in what we call Libera eBPM application, which is very good to support and to debug in case of bugs. We keep improving our instruments. We don't just stay and watch them fade away, but we do these improvements continuously. And this was reflected in, let's say, in the last 1.5 years. I counted approximately 2 engineer years, which were invested into the hardware and software upgrades. I mean, this development was spread over a couple of development projects. So yeah, that was the end of my presentation.